Welcome to the Mathematics board. In this session, we will learn refractive index. So before this, we recall refraction. So we all know that light travels in transparent medium. When it travels from one medium to another, it changes its speed. The medium from which light is traveling, it is called the incidence medium. You can see here light rays is traveling from this medium here. This arrow shows that this is the light entering here, and in which medium it is going to enter. This light is going entering here, so this medium is called here refracted medium. If this refracted medium is dense, the light slows down its speed. You can see here this ray is bending closer to the normal, and when refracted medium is rarer in compared to incidence medium, light travels fast in refracted medium. So this ray shows light travel faster and it bends away from the normal. So this is the refraction, and whenever you have the denser medium, then light's speed will go slow here, and in rarer medium light travels very fast. Why? I am going to give one example here. If you are going on a free path, there are no people, obviously you can go very fast without any obstacle. And if you are going on a path where are very people, very crowd here, then obviously these people will give you obstacle to walk you, and obviously your speed will go slow and you cannot move very fast in that crowd. So here this happens with light traveling also. The denser medium, there are more and more particles closer to each other, and they shows the obstacle in the light path to travel. So light slows down its speed. And rarer medium, the particles at very distance, more free path available for light traveling. So light travel very fast in rarer medium. So how much faster or how much slow is any medium? So we can get this by study of refractive index. So we can say that refractive index is the measurement of how much any medium is denser or rare, and the second, in any medium, how faster or slower light travel in the medium. So refractive index gives these two values to us. So sometime, and this density is also called optical density. This is not mass density. This is called optical density. Optical density or refractive index also. So sometimes many people use the sign for refractive index N, and many people use the mu sign for refractive index. So what is the formula for refractive index? We can say just like as this is incidence medium is here air, and this medium is glass. So how can we write the formula to find out the refractive index? So here incidence medium is air. So in language we can say find out the refractive index of glass with respect to air. This means light traveling from air to glass, light entering into glass from air. So here incidence medium is air. So we can say here, right here the formula, we have to find out the refractive index of glass with respect to air. Velocity, one thing more also you know, refractive index is inversely proportional to velocity. We have already seen in denser medium, light speed decreases, and in rarer medium light speed is increasing. So it's obviously inversely proportional to the velocity or speed of light refractive index. So whenever we have to find out the refractive index, so once we write the formula refractive index of glass with respect to air. So we have written here refractive index of glass divided by refractive index of air, or ratio of refractive index of glass to the refractive index of air. If we have to written the formula in terms of speed of light, so we know that now refractive index is inversely proportional to velocity or speed of light. So whenever here refractive index of glass, so we will use here speed of light of air, speed of light in glass. It will be inversely proportional. Just like that, you have to find out the refractive index of water. So write the formula, learn how to write refractive index of water with respect to air. So refractive index of water with respect to air. So we have written here this formula, refractive index of water divided by refractive index of air. So in the term of speed of lights, we will use here inversely proportional to velocity or speed of light. So speed of light in air, speed of light in water. So the refractive index of water with respect to air, it is the ratio of speed of light in air to the speed of light in water. So like that you can find out the formula and value also. So just put these value. If in air the speed of light is 3 multiplied by 10 to the power 8 meter per second, and in glass the speed of light 2 into 10 to the power 8 meter per second, and light travel from air to glass. Light travel from air to glass. So we have to find out the refractive index of glass. Refractive index of glass with respect to air. So we will write here speed of light in air, ratio of speed of light in air to the speed of light in glass. So we will put here value 3 into 10 to the power 8 upon 2 into 10 to the power 8. So what is the value here? 1.5. So one more important point is here, refractive index has no unit. It shows, what does it mean? 1.5 is refractive index of glass with respect to air. So there is glass is 1.5 times denser than the air. Refractive index gives us this information. This is glass is 1.5 times denser than air. So one more point, note down refractive index, no unit, and you have refractive index is inversely proportional to the speed of light in the medium, and refractive index is the measurement how much any medium is denser or rarer, how faster or slow light travel in medium. So you can write that. And one more thing, refractive index is always, you will get either greater than 1 or less than 1. It will never be 1. If you get refractive index 1, then what does it mean? Incidence medium will be equal to the refracted medium or same refractive index. If there is air to air, then light doesn't bend here. It goes without bending straight down. So you will get here 1. Whenever you get here refractive index 1, then it is incidence medium and light travel in the same medium. This means light travel in the same medium. If you get refractive index is greater than 1, like that we have find out the glass refractive index with respect to air 1.5. So we can say here the refractive medium is denser than the incidence medium. And if refractive index is less than 1, then we can say the refractive medium is rarer. Refractive medium is rarer than the incidence medium. So these points will help you to understand refractive index. One more time, I am going to revise. Refractive index is inversely proportional to speed of light. Second thing, refractive index has no unit. And the third point, refractive index is either greater than 1 or less than 1. These point. And what is the refractive index? And this is the absolutely refractive index. Whenever you find out the refractive index with respect to air, always you are going to find out any medium like that glass, water, kerosene or diamond, any of medium, you are going to find out the refractive index of any of these medium with respect to air. So you will find out the absolutely refractive index. So you have to use speed of light in air divided by speed of light in the particular medium which you are going to find out, glass, water, diamond. So let's check some mathematical numerical questions also we can do, then you can understand very well how to find the refractive index. Just like that, here we have written 2 questions. Question number 1. Find the refractive index of diamond with respect to water. If the absolute refractive index of diamond is 2.42 and refractive index of water is 1.33. So we have to find the diamond refractive index with respect to water. So how we write the formula? Refractive index of diamond with respect to water. Here we have already given absolute refractive index. So we will write the refractive index of diamond, ratio of the refractive index of diamond to the refractive index of water. So we will put the value here. Refractive index of diamond is 2.42 divided by 1.33. What does it mean? We have to find refractive index of diamond with respect to water. Means here incidence medium is water and refracted medium is diamond. Means, second thing, light traveling from water to the diamond. So we have to find the diamond, how much denser or rarer diamond is with respect to water. So it will be 1.82. So this means this refractive index of diamond means it is the 1.82 times denser in compare of water. So you have to solve these type of questions also. And one type of question is here. If speed of light in water is 2.25 into 10 to the power 8 meter per second, and speed of light in glass is 2 into 10 to the power 8 meter per second, then find the refractive index or optical, this is also called optical density, I have told you. So density of glass with respect to water. What does it mean? Incidence medium is water here. Incidence medium is water, means light traveling from water into glass, and refracted medium is here glass. Refracted medium is here glass. So how to write down the formula? We have to find out the refractive index of glass with respect to water. So refractive index of glass with respect to water. If you have confusion, then once you write down the refractive index of glass, ratio of the refractive index of glass with respect to water. Ratio of the refractive index of glass to the refractive index of water. Now we have given the speed of light, not given the absolute refractive index of glass and water. So we have to write here formula in terms of speed of light. So I have already told you the speed of light is inversely proportional to the refractive index. So wherever mu g means refractive index of glass, then you have to write here speed of light in water, and ratio of speed of light in water to the speed of light in glass. So this will be the formula. You have to find out the refractive index of glass with respect to water. So now put the value. Speed of light in water is 2.25 into 10 to the power 8. Now in glass, speed of light 2 into 10 to the power 8. So you will have the value for it 1.125. This means the glass is 1.125 times denser than the water. This means how much denser glass is in compare of water. Refractive index gives us the information how much denser is any medium. So glass is 1.125 times denser than water. So like that you will calculate any numerical questions of refractive index, and this is the explanation.